Hi everyone, this is Jagan. Today we are going to talk about a few more concepts in permissions. In last class we have discussed about the permissions like default permissions for the root users and the default permissions for the normal users and what is the command to change the permissions for the groups and others as well. And So with not only with the help of the numbers like 7, we have numbers, right? Like default permissions for the numbers. So in addition to the numbers, we also have letters like user, U, groups, G, and others. So with that also we can change the permissions, users permission, groups permissions as well. And the command that we have used to change the permission is chmod plus or minus plus to add the permission g and colon and name of the group and the type of permissions they require uh, and the name of the file or directory. So this is how we have used to change the permissions. Now today I'm going to talk about the few more concepts in permissions. That is a sticky bit. Sticky bit is generally what happened is you all permissions are granted like read, write, execute. Permissions granted in directory, but there are the chances that anybody can delete, anybody can access the data because it has all permissions. Okay, let's say chmod. Generally, when we create a directory mkdir Mm, files list. When I create mkdir directory, okay, when I create directory mkdir, generally what happens? Normally the permission default permissions for the directory is 755. So this what it happens when the directory is created. Okay, so if I want to grant complete permissions, chmod 0777 on directory files list. Okay, so now here we have granted complete permissions 0777. Here, if all permissions are granted, then what happened? A is the member, A is the A wanted to create a file. File, what is the name of the file? Let's say file by A. So this, so he has created one file. B also wanted to create one more file. B wanted to create a file known as file by B. So both A and B have created their own files, file A and file B. So in where did they create the file? They created the file in files list directory. Okay, so in files list directory. So both of them have created in a files list directory. So A has created the file and B also created the file. And so if they have created file, so A mistakenly or intentionally, accidentally or intentionally has created B's file. So and B also did the same thing. So to avoid such scenarios or to avoid misuse of the privileges given or granted to the users, we have a concept called sticky bit. Okay. So the sticky bit, It is a special permission granted to regulate the access over directory. To regulate the access over the directory, the special permissions is granted. The sticky bit is a special kind of permission. Okay. Now, how to apply the sticky bit? CH mode here, chmod 0777 is a normal permissions. When we apply the sticky bit permissions, how it looks? chmod 1777 files hyphen list. So when we apply the sticky bit, if we apply the sticky bit with a number, then excuse me, then 1777 is the way to apply. If you want to apply the permissions with letters chmod plus t slash files list. Okay. Now after applying a after applying sticky bit, a cannot delete b's file and vice versa. So A cannot delete B's file and B cannot delete A's file. So that's how it affects when the sticky bit applies. Okay. Now let's see practically. Okay. One more thing I just wanted to know is the sticky bit is only applied by the root. Root has privileges to apply the sticky bit permission. Root has root root only has the privileges to apply the sticky bit permission. So apart from the root, nobody has the right to apply the sticky bit permissions. That you need to remember. Okay, okay. Let's get into practical. Uh, who am I? Who am I? Root. This is the root user. Okay. Now let's mkdir. We want to create the directory files list. Okay, so the files list is created. Let's see whether file is created or not. Change directory slash ls hyphen l. Yeah, here we have created the file. We have created directory files list. Okay, so now the files list is created. Now let's see what are the default permissions the directory has. ls hyphen l d files list. So default permission is, as we know, 755 is the default permission for the directory. When the directory is created, default permissions are 755, like read, write, execute, read and execute, read and execute. Read, write, execute is for root, read and execute is for group, and read and execute for others. Last one from read and execute is others, and second is the group, and the first is root. Okay, now let's change the permissions for the root directory. Change the permission is nothing, just giving all, granting all permissions like read and execute for groups and others. Root has already all permissions. The group, let's grant all permissions to the group and others. So how to grant the permissions to the root and the others? Chmod 0777. This is normal permission. 077. We are not applying sticky bit permission. We are just applying. We are normal permissions. Normal permissions granting all permissions. Read, execute to groups and others. Slash files list. Now let's see whether the it has all permissions or not. ls-ld slash files list. If you see here, we have granted all permissions, read, write, execute for group and others. Okay, so when the all permissions are granted, all permissions granted for group and others, the directory looks like this, highlighted with a blue color. Okay, you see here. So whenever the directory has all permissions for all type of users like groups and others, then it looks like this. Okay, now we have a granted all permissions. Now let's say we have a users like let's see who all are users in our directory. Sorry. Okay, we have a users like let's take Rom and Krish. Okay, hmm? Rom and Krish. Now see, this directory has all permissions, so who anybody can other see anybody can create the file or delete the file or execute the file. That is what this full permissions mean. Okay, su hyphen rom. So rom has logged in. So who am I? See rom. Okay, rom has logged in. Now rom wanted to create a one file. Okay, now rom is in files list directory. Present directory. If you see, he is in files list directory. Now he wanted to create one file. File by rom. So file by rom. Now he has created the file. Let's see what. Yeah. So now the file has been created by rom. Rom has created the file. Okay. Now let's log off. Now we have one more user known as Krish. Okay. So Krish wanted to log in and create a file. Okay. Now Krish has logged in. If you see who am I? If you see who am I, so who has logged into this? Krish. Okay. Now Krish wanted to create a file in the directory known as files list, because here See, they are not part of the group. Okay, they see Ram and Krish falls under others category. Therefore, they can under these others have permissions like read, write, execute. Therefore, they can read the data, they can write the data, they can execute the file also. Okay. Now, Krish has logged in and he wanted to create a file in files list directory. Change directory slash. Now, see, we can only see only the file which is created by the RAM. Now, Krish wanted to create one more file. Touch file by Krish. Let's see whether file is created or not. Let's say L. See, so here we can see here the file is created by file is created. So who is created? Krish. And we can see here both Krish and Ram files we can see in files list directory. Okay. Now see, Krish has created his file, and Ram also has created his file, Ram file. Now, Krish wanted to delete the Ram's file. Okay, let's see whether he can delete the Ram's file or not. Because here we have given the permissions: read, write, execute. Read the data is only read the data. Write is to modify, create, modify, and delete. That is what the write means. Write permission is yeah, write permission is creating the data, modifying the data, in deleting the data. There is a write permission is all about. Okay, now let's see whether he is going to create a file, whether he is going to delete or not, whether he has a option or a permission or privilege to delete the file or not, which is created by ROM. Okay, rm hyphen rf file by RAM. Let's see whether file is deleted or not. Yeah, file is deleted. Let's see whether file is deleted or not. ls hyphen l. Yeah, the file has gone. File has been deleted. So who has deleted the file? Krish has deleted the file. Whose file? This is Ram's file. The Ram's file has been deleted by the Krish because it has all permissions. So anybody can delete anyone's data. Okay. So now su hyphen ram. Ram, your account has expired. Okay. Okay. Exit. Okay. Again, Krish has logged in. Okay. Now he wanted to get into the directory. Now ls hyphen l. See, he has only the file which is created by the Krish. Okay. So here, uh, only Krish has a login. Sorry. S exit su hyphen ram. Okay. Rom has login. Okay. If you see who am I? So if you see who am I, the ROM has logged in and he wanted to delete the ROM's file. Okay, so change directory files list. So where is he currently now? So he is in files list directory. Now if you see here, what are the files that we have in a ls-l? What are the files in a files list directory? The file which is created by the Krish. So ROM's file has been deleted by the Krish. because no here all permissions are granted, read, write, execute permissions. Therefore, anybody can delete anyone's data. Let's say whether Krish Ram also be able to delete the Krish file which is created by the file by Krish. Okay, rm hyphen rf file by Krish. Oh, the file is created. Let's see whether the file is created or not. ls hyphen l gone. See here, no file is there. See here it what happened is ROM's file is deleted by the Krish and Krish file is deleted by the ROM. So since here all permissions have been granted, read, write, execute permissions. These ROM and Krish falls under others category. They can delete anyone's data. So here A can delete B's data, B can delete A's data. A has deleted B's data and B has deleted A's data. Therefore, because it has all permissions, to avoid such a misuse of the permissions, in spite of all the permissions granted, we have a sticky bit. Okay, now uh, okay, first see let's create the file. Okay, anyhow they have uh, anyhow they have deleted all the files. Okay, now let's create the file again. uh, no, thus users, by the users who are in who have deleted their others file. Okay, now let's create the file one more time. Touch touch file by rom, file 1 by rom. Okay, ls hyphen l. Here file by rom has created the file. Okay, su exit su hyphen krish. The krish has logged in. Who am I? The Krish has logged into the file and he wanted to create his own files list. So he is in files list directory. If you see here slash files list, if you see here what are the files that in files list directory, the file which is created by the RAM we can see here in file 1 by RAM. And Krish also wanted to create a file. Let us create a file. Touch file 1 by file 1 by Krish. Okay, now file Krish has created a file. Let's see whether file is created or not. Yeah, the both files which are created by Krish and Ram we can see in files list directory. Now see if you see I already said that only the root has the privileges to apply the sticky bit. We'll see whether he is able to apply the sticky bit or not. Change directory and chmod plus t to which directory? Files list directory. Operation not permitted. Therefore, he falls under others category. Therefore, he doesn't have a privileges to apply the sticky bit permission. Then who has the privilege to apply the sticky bit permission? Root. Root only has the permissions or privileges to apply the sticky bit permission. Okay. Now let's get out of here. And who am I? Who am I? Who is the now currently logged in? Root. Now chmod. Now he plus t is the this is one way. Another way is 17777. That also we can apply. So if you want to see, I'll apply it. Okay, plus t files list. And one more thing is ls hyphen l slash files list. See ls hyphen l slash. See here, files list, read, write, execute. It has all permissions. This is before the sticky bit permission, sticky bit. Now after sticky bit, we will see one more difference here, one slight difference here. On behalf of instead of X, the T appears here. Okay, chmod 177 slash files underscore list. Now the sticky bit is applied. Let's see whether the sticky bit is applied or not. ls hyphen l slash files list. Okay, okay. ls hyphen l d. See here, if you see here, in place of in place of x, t is appear. Read, write, execute, read, write, execute, read, write, and t, because we have applied sticky bit. Now we have applied the sticky bit. Let us see whether Krish is able to delete the RAM's file, and RAM is able to delete Krish's file. Okay, uh, su su hyphen RAM. Now who am I? RAM. So RAM has logged in, and he wanted to delete file which is created by the Krish files list. Okay, currently where is in? He is in files list directory. So what are the files? The file one by Krish and file one by Ram. Now Ram wanted to delete a Krish file. Okay, let's see whether he is able to delete the Ram Krish file or not. rm rf file one by Krish. See, operation not permitted. That is the beauty of the sticky bit. Though all permissions are granted, but one cannot delete others' data. You got it right. So operation not permitted, because now we have applied sticky bit. If we don't apply the sticky bit, then I have shown you example with example what happens. It's obvious the file will be deleted. Okay, so if once we apply the sticky bit, one cannot delete others data. Okay, now he is not able to delete delete the file which is created by the Krish. Let us see whether the Krish is able to delete ROM's file or not. su exit su hyphen Krish. The Krish has logged in. Who am I? Sorry, who am I? Who am I? Krish. Okay, now change directory files list. Where is in? He is in files list directory. What are the files that are the file which is created by the Krish and Ram? Okay, now Krish wanted to delete the RAM file. How to delete the RAM file? What is the command? rm hyphen rf file one by RAM. Operation not permitted. So that is the beauty of the sticky bit. So one cannot delete others data once the sticky bit is applied. Okay, so you need to understand the beauty of the is the sticky bit permissions. So so this is the one way, 17177, this is the one way. Another way is plus T files list to apply the sticky bit. Okay, and how to so plus is to apply, minus is minus T is to remove the sticky bit. So here everyone has all permissions like read, write, execute. Once we apply the permissions like 077, uh, so everybody has the permissions. Everyone can, so everyone can uh, write, modify, and delete the data of others. So once Stickybit permission is applied, then uh, one cannot delete others data. So one cannot delete others data. So that is the beauty of the sticky bit. Okay, though it seems like all permissions have been granted, but like read, write, execute, but one cannot delete others data, as we have seen already in with example, right? Okay, now that's that is what the sticky bit is. Okay, sticky bit. Now I'm going to talk about the one more concept that is known as access control list. See, access control list. For example, just to think like that, we have a one critical or important directory. We don't want everyone to have access to that directory or a file. So in such a scenario, we just want only the few people, like one or two people, to have access to the directory. So what we do, we use the access control list. Controlling the access. Okay, controlling the access and just giving the access to particular user, particular group, or specific user, or specific group. Okay, now how to provide access to the particular user or particular group is, let us see. Okay, all right. Now the, with with access control, with access control list, we will be able to provide our provide our provide our grant access to particular user or group. Okay, let's say uh, mkdir mkdir make directory uh, uses not uses, let's say db data. Okay, now we have database data. This is very critical important, so we don't want everyone to access this data. We just want only one or two people to access this directory. So generally when the directory is created, what are the permissions? Default permission is 755 is the default permissions. Okay, now I'm going to change the permissions chmod 0700, which directory? db data. So now I've removed all permissions for groups and others. Only a root has all permissions. However, I can provide access I can provide access to this directory for anyone. I can provide access to anyone for this to have access to this directory. Okay. Now, so this is the no controlling the directory access permissions. And before that, I just want to let you know that before we applying the access control list, we need to ensure that access control list is also applied on mount point. Okay. Now, access control list applied on mount point. So this is the syntax. See, set FACL set file access control list. Hyphen R is recursive. Hyphen M is multi options. U is for user, and this is the permissions list. Okay, and the directory name. So this is the example. Okay, let us see the practically. Okay, okay. I'm going to create the one more directory. mkdir mkdir db hyphen data db hyphen data permission is done. Okay, Krish login, right? Exit mkdir. So mkdir db data. So root has created a one directory in a slash root. Okay. So what are the permissions? ls hyphen ld db hyphen underscore, sorry, data. So he has obviously he has a default permissions like 755. Now let us change the permissions. chmod 70700 db underscore data. Now the permissions have been changed. Okay, let's see what the permissions. ls hyphen ld db underscore. Now, if you see here, earlier the default permission is 755. Now, the permissions have been changed. Only rewrite execute only for root. Okay. And no permissions for the group and others. Group is the root also, but any other. Here we are ensuring that only the root has all permissions. Read, write, execute. Nobody has any permissions. Because once we grant the permission, then obviously it will be a different concept altogether. Therefore, we just trying to focus on access control list. What is an access control list is the main objective of the access control list is to provide access to the particular user by by having no permissions for the groups and others. Only we just want to provide the any kind of permissions, read and execute to the particular group or particular user. Now I'm providing access to the particular user. Okay. Now, okay. So here we don't have any permissions. Okay, for the groups and others. Now I wanted to let's say uh, a RAM su hyphen RAM. Sorry, su hyphen RAM. ROM has logged in. Okay. Now ROM wanted to get into the ROM wanted to get into the directory. Okay, let's see whether he's able to get into the directory or not. Okay. Now where is he now currently? Slash. Okay. Change directory db underscore data. So permission is denied because he doesn't have permission. Now let us grant let us grant permissions to this particular user. Okay. So what is the command? Set FACL. Okay. Hyphen R. That is recursive because this is the way, this is the directory. So in recursive, as I already explained about the recursive option. So in addition to the single, the permissions also granted to the subdirectories and subfiles. Sorry, if we add the option hyphen capital R and hyphen capital hyphen M is multi options, and U is for user. And what is the user we are granting the permission ROM. So what are the permissions? Read and execute. Okay. Now on which directory? db underscore data. So data on data directory, we are granting the permissions. Okay. Sorry, ROM is granting his files. Okay. Permission is not denied. Let's exit now. You see, only root has permissions to to grant root has a privilege to grant permissions to particular user. Okay. Set FACL hyphen R hyphen M U ROM read and execute. Okay, we have set the permissions. We have given the permissions to ROM. Okay, now let's see whether he is able to get into the directory or not. Okay, su hyphen ROM. ROM is logged in. If you see who am I? ROM. Now what is his current directory? Slash home slash RAM. Now he's in so earlier he is not able to get into the DB data directory. Now he is able to get into the DB data directory. Okay, because we have given the permission read and execute permissions. Therefore, he is able to get into the directory. Earlier, it's not like that. This is the uh, this is the access control list. Okay. Now we have given the access to the user. Okay. Now let's see how to grant the permissions to the particular group. Okay. Let's exit. And what are the groups that we have? Slash etc slash. So we have a group called Redhat admins. Okay. We'll see how to grant permission. Uh, Set FACL. Okay. And hyphen R hyphen M. Now we are granting permission to the group. Therefore, the letter should be G. And what is the group name? Red Hat admin. And what are the permissions that we are trying to give? Read, write, and execute. Okay. On which directory? DB data. Now we have granted the permissions to which group? Red Hat admins. Okay. Now who are the members of Red Hat admins? Let's say LID hyphen G. Uh, Red Hat admins. Okay. Yeah. See, Red Hat admins. Karthik, Krish, Ram, part of uh, the part of which group? They are Red Hat admins. Okay, they are members of Red Hat admins. Okay, okay. Now, uh, so this is the we have granted permissions to the particular user. If you want to know what are the permissions and who has all permissions to the particular directory, we have a command known as get facal slash db hyphen sorry underscore data. So if you see here, only ROM has the permissions. That too, what kind of permissions? Read and execute. In addition to the ROM, we have granted permissions, Red Hat admins. What permissions we have granted? Read and execute. So in Red Hat admins, who is the members of this group? Karthik, Krish, and Ram. Okay, now ROM has permissions known as read and execute. Let us see whether Krish is able to get into the directory or not, because Krish is a member of Red Hat admins. So we have granted the permissions to the Red Hat admins group. So su hyphen Krish. Krish is logged in. Now change directory slash. Now currently he is in slash directory slash root directory. Now he wanted to get into DB data directory. Now he is in a DB data directory because see, you need to understand ROM we have granted the permissions to particular user, that is ROM, and we have granted a particular permissions to the group, that is Red Hat admins. Now who all are members of Red Hat admins? Karthik, Krish, and Ram. Now Ram Ram is also Ram has been given the permissions. Now Krish is a member of the Red Hat admins, and the group has a read write execute permission. Now he is in DB data directory because he has a read write execute permission. Now he is able to create the file also. Okay. Now let's say touch file by Krish. Yeah, he has created the file. Let's see if the file is created or not. Yes, file is created by the Krish because he has got all permissions. Read, write, execute. Let us see whether ROM is able to create ROM is able to create the file or not. Execute su hyphen ROM. Now ROM is logged in. If you see, who am I? ROM, and change directory db underscore data. Now he is in a db data directory. If you want to ls hyphen l. Now currently we can see only one file which is created by the Krish. Now touch file by RAM. Permission denied because we have granted only what permissions, read and execute permission to this particular user. But the Krish is part of a Redhat admins, which has all permission read and execute. So this is how we can see with this what had happened. So with access control list, we can control the access to the user. Okay, we can grant a particular access to the user or directory. So access can be anything. If we want to see uh, only the data, then we can grant only the read permission without granting write and execute. If you want to if we want the user to modify or create or delete the file, we can grant the permission. Right, we can grant the write permissions. So that is the beauty of access control list. We can you know we can control or regulate, or we can provide access to the particular user or group. That is the beauty of access control list. So we have seen a sticky bit and access control list. I hope this is very clear to you, clear to all of you. Now let us exit ls hyphen ld slash db hyphen data. So here, if we apply the access control list, the last you see here the plus symbol. You can see here the plus symbol. Okay, clear. So let's see what are the permissions have been granted. What are who has access to this DB data directory. So we have already discussed what is the command get facl slash db hyphen sorry underscore data. Sorry, get facl. So this is the name of the file. Owner is the root and group is the root. And uh, user is the RAM. Okay, we have granted the permissions to only one user, that is RAM, and he has read and execute permissions. Okay, and the group we have we have provided access to Red Hat admins, and the Red Hat admins, the group has all permission read, write, execute. And Krish is a member of the Red Hat admins, so he created the file in db underscore data directory. So the command to know who has access or who is a part of access, who has access to this directory is get facl. Okay, set facl is to provide access to the directory. Get facl is to know who has access, who has access to the directory. Username. This is for user. Okay, granting. Granting the permissions to the particular group. Okay, username group. So the example to grant the permission to the particular user is set facl hyphen r hyphen m u Username, we are granted the permission to the ROM, therefore I'm adding here. What are the permissions we have granted? Read and execute, right? And what is the name of the directory? db underscore data. So this is for this is for granting permission to a particular user. Okay, and group what that we have provided access is, what are the default permissions we have? Uh, I know what are the permissions that we have provided to particular group is group Red Hat admins. What are the permissions that we have granted to Red Hat admins? Read, write, and execute. Okay, the directory is db data. So this is the way to example writing. And the command to, what is the command to apply ACL? This is a command. Okay. Now, what is the command to get the get ACL permissions? Get FACL, get FACL hyphen, sorry, slash directory. Example, get FACL slash, what is the directory on a db hyphen, sorry, underscore data. This is a syntax, this is a example. Okay, now I hope this is very helpful. Sticky bit and access control list. This is access control list. So I hope this is very helpful and informative. And this to provide access to particular user, we use access control list. Okay, to avoid any misuse of the permissions, like though all users groups have all permissions read, write, and execute, but to avoid any misuse of the permissions, to not to delete the sambas data, we use the sticky bit. I hope this video is very helpful and informative. And if you know if you get something out of this my video, please like it, share it, and subscribe to my channel and keep watching my videos. And have a nice day. Goodbye.